This is a simple overview on some area calculations that you'll find useful for the fundamentals of survey exam. The scenario I want to address here is one that you can reasonably expect, and it regards the area of a sector of a circle defined by the radius of the circle, and a central angle we'll call delta here. So we're going to calculate not only the sector area, but the segment area. The segment is the area between a chord C and the arc. So we'll calculate that included area shortly. In our scenario here, delta will be 75 degrees, and we'll use a radius of 100 feet. You'll remember that the area of a circle is pi r squared, and then when we are taking some fraction of that circle, well, the fraction in this case is described by an angle delta, and that is a fraction delta over 360. So when I plug the numbers in, it's a real simple thing. Pi times the radius squared times our delta over 360. You'll see that the degrees in delta and the degrees in 360 cancel, leaving me square feet. So this gives me a value of 6545 square feet. This is the sector area, isn't it? Okay. Now, from your fundamentals of surveying test booklet, you will find a list of formulas. In fact, I would recommend getting the Fundamentals of Surveying Sample Questions and Solutions book that's available from NCEES, and we have links to NCEES here on the Wikipedia page. You'll find an example of that summary of equations and mathematical relationships that will be useful for your exam. And the nice thing in this case, it tells us that the area of the segment is the area of the sector minus the area of the included triangle. So we have already solved for this amount, and then we take the included triangle, which is this, subtract it, and then we will get the area of the segment. So, moral of this story is make sure you are well versed in the contents of the available formulas and mathematical relationships given in the Fundamentals of Surveying test booklet. That'll be an important part of your studies. So, if I'm crunching numbers here, we already know the first answer, the first component of this relationship, and I plug in the radius, square that, times the sine of my delta angle all over 2. And in this case, I will end up with, let's find it here, 6545 square feet minus 4830 square feet. And that, of course, if I do my simple arithmetic, is going to give me 1,715 square feet. Does this make sense? Well, yes, because the area of the triangle that we're taking out is very similar in size to the sector. The remaining segment should be a bit smaller in this case, shouldn't it? So, fairly simple area problem, one that you can expect to see some variation on in your Fundamentals of Surveying exam, but my point with this is for you to be familiar with the formulas given in the Fundamentals of Surveying test booklet.